Hi. In this video, I'll be talking about fixing up the ontology that is being generated by FAIR materials so that we would not have issues with the ontology, and then the mapping becomes clear, so does the relationships. And after that, we could pipeline these ontologies into FAIRLinked so that you could convert the data and metadata that you have into RDF representations so that we can go about doing reasoning about your data to derive specific insights and pipelining lots of automation. Now, let me quickly share my screen and then we'll talk about this. Okay, sure. Right. So previously, I talked to you guys about the different ontologies, and I just want to clarify this thing real quickly. So these green terms, right? The reason they are also here is because these are terms which could be reused across all the domains and subdomains within MDS Onto. So that is the reason why they're also here. And I kind of talked about it inside of Onto Concept where we have these different domains and also a whole bunch of different layers, which eventually lead to one of these subdomain ontologies. Now, again, I kind of wanted to drive home that let's say there are a whole bunch of ontologies within MDS characterization, for example. We want to make sure that we abstract out a MDS characterization concept ontology at this level, which tells you what are the terms that are common to all the characterization ontologies so that no one goes about trying to redefine or trying to come up with a term that is conceptually equivalent, but it's just a duplicate of a term that someone else has already defined. So that is the reason for creating a concept ontology. So this yellow box, right? This is kind of similar to, or if not, it is congruent to this yellow box right here. So that is exactly all these terms. So you want to make sure that terms that are applicable to all the different domains and subdomains are defined out here. And also your connection to a mid-level ontology. So that is also defined here. And when you go down the layers, right, you want to make sure that one of these domains, it has a concept ontology, provided that there are shared terms that could be applicable to two or more ontologies that is present as a subdomain within this domain ontology. I hope that kind of makes sense. It is just in hierarchy. So think about it as object-oriented programming, right? You have a parent class, such as animal, for example, and then you have dog, you have cat. You want to have like common properties between both dog and cat inside of the animal class, such as, for example, they can both walk, and then they have like a voice, for example. And then if you go down to a dog and if you go down to a cat, and then cat meows and dog kind of barks. So that is a loose example of what I'm trying to get at, which is basically that if you figure that two or more ontologies within MDS characterization, for example, they have shared terms, you want to make sure that you put those shared terms in their lowest common ancestor, which is MDS characterization. So at this level, you create a concept ontology and then declare that it is something that people could refer to when they're trying to see, hey, I'm creating a new ontology within MDS characterization. Do I already have this particular term, which could be something that all my neighbors at the same level could share? So you think about whether you should add to this. Now, again, like this might seem like more work, but the goal here is we don't want to have conceptual duplicates. I mean, that's the point of this. So you want to reduce the number of conceptual duplicates that we will possibly have. I came up with this script called MDS onto concept generator. So you can check it out. It's on GitHub and as well as in our Bitbucket. So that is something that I also want to talk about. So just to go back to this top level, so the reason why these green terms, which extend upon MDS terms, are here beyond just the pure mapping to a mid-level term, is because these are terms that could be shared across all the domains and subdomains. Now, back to the purpose of this video is that I want to talk about the ontology which was generated using FAIR materials. All right. So I previously showed in my previous video that, I wanted to generate a low-level XRD ontology. And again, like I pipeline all the sheets and I got an ontology out of it. And I just wanted to show you guys what went wrong with it and then what I did to kind of fix it. So let's look at the low-level one first. Okay. Actually, let me just pull up the combined ontology so it's kind of easy to look at. Okay. All right. So if you look at this combined MDS onto first, right? So the first thing that strikes out is, all right, so we define an XKO as broader as an object property, great. But look at this RDFS domain, right? This is very confusing because you do know that there is a relationship that starts from one of these nodes and ends at one of these nodes. But the thing is, which of these two sets of nodes is connected? That is the question. So this becomes a problem with the current iteration of FAIR materials. So that is something that FAIR materials needs to fix. And I will show you how I kind of fixed in the ontology that I've made. This is one thing that we need to fix. The other thing is that look at this one value, right? So this is based on the value type definition sheet that we fill up during before we pipeline into FAIR materials. See, again, we know that these have one of these value types, but which one? Like, is station having a value type of float or is it having a value type of string? So that is the question, right? So if you put this into the WebVals server, right? It kind of shows it as a OWL union. So it gets confusing as to who is the source node, who is the destination node. And we know that this is the relationship they have, but which two of these nodes is connected? Okay, so that is a question. And I had to do some kind of like scripting to fix that. And I will show you my final corrected ontologies. So first is the low level ontology, right? So in that low level ontology, this is what I did. So let's go back to the low level. In the low level ontology, what I really wanted was a bunch of XRD terms. So these are all the top level ontology terms, which I'm going to subclass off in this ontology. So facility is a subclass of laboratory, for example. And then this is the stuff that I want to collect data on, right? So I want to collect data on step number, log file, image sequence, and so on and so forth. The relationships here are defined between these green terms, right? So for example, X-ray detector and detector name have a relationship called MDS has identifier, which is a subproperty of PMDCO identifier. So this is not something like a definition. So do not use this. You would want to make sure that you have like a proper definition. Again, like even in my variables, like some of the sheets, I might have missing different definitions or missing units. Pardon me for that. That's because the purpose of this is a proof of concept. So that is the purpose of this demonstration, is just to show you what went wrong and how to make sure that you prep your sheets and ontology so that you could use the FAIRLinked package to convert your data sets from being tabular, proprietary specific data sets into liberated data sets that are represented in RDF. Now, going back to what I did, so these are all the terms that I want to collect data on. These are the relationship, value type definition, and I ran into the same issue that I showed you guys just about a while back, where I don't know which one of these have a relationship with which one of these, so that becomes a problem. Although I know that MDS value is the relationship that any two of these terms share. So what I did is finally I corrected them. And then let me show you this low level ontology, right? Let me pick up Sublime. Sublime. Right. Nice. Cool. So first off, right, what I did was I declared these relationships. So I said MDS characteristic of is an object property, and it is a subproperty of PMDCO characteristic of. So this is one feature which fair materials does not currently have, which is subclassing relationships. That is something that fair materials has to work on and implement those features beyond just subclassing variables. Likewise, I did so for all those relationships and other stuff like data properties that I'm subclassing off. So for example, MDS value is a data property, right? I kind of created a subproperty of PMDCO value. So this is what I've done. So made sure relationships extend upon PMDCO or some kind of mid-level ontology term, which connects all the way to BFO. Now, moving on, this is the other thing that I wanted to say. See, previously we had that whole MDS value is a object property, and then we had that whole thing about it being that range and the domain, right? So let me just pull that one again to show you guys what went wrong in the previous one. So, okay. Oops. All right. So you see this. Okay, have a look at this stuff, right? This is what I was talking about. So you have an MDS value, but you don't know which two of these are connected to each other, right? So what I've changed is that I've clearly indicated that MDS facility has a value type, which is string, and so does station, and all this stuff, right, which is kind of aggregated here. I broke it down into its specific, class definition. So facility, you have a value of string, and sync X-ray detector, for example, it does not have value. That's fine. And also about unit, right? So pixel size has unit, blah, blah, and so on and so forth. So all those relationships are properly captured here as compared to earlier. And also there was this broader thing. So I will show you in different ontology. Low-level ontologies do not have SKOS broader relationships typically. So I'll show you the other one right now. And if I go to final corrected, my top level ontology, for example, so on the right, I have my top level ontology again. So this is what I've defined for SKOS broader, right? I've defined that SKOS broader is a RDF property, which is also a hull object property. Gave it a comment. I also said where it is defined by, and also mentioned its label as well as its definition. So I've included all of that cool stuff. And then I also define all of the relationships which subclass a PMDCO relationship, for example. And then this exactly follows the sheet that you guys saw for top level. So all the PMDCO terms are defined first, and then my MDS terms, which extend upon the PMDCO terms, and also connection. So one thing I want to kind of draw here is you see that XKO is broader, right? Look at recipe file path, for example, and then look at recipe file path. Does it exist right here? Okay, maybe I added recipe file path after. Or let's just look at result ID, for example, or sample ID. Let me see what comes to my mind first. Yeah, okay. Look at result ID, right? We found result ID. Result ID exists here as well. Result ID, I don't even know who it is connected to when it comes to the broader relationship, right? So now I explicitly mentioned that result ID is broadly related to MDS result. So these are the things that I had to fix up manually just to make sure that my ontology is correct, and then the code doesn't get confused which two terms are related to each other. So this is what you exactly needed to fix up. And as an input to the package, right, I'll tell you what exactly it needs for you to do the mapping. Yep. So let's go back to this draw.io file and let's talk about onto analyzer, right? Cool. So essentially for you to generate this data ingestion sheet, imagine you're going into a laboratory to take measurements today, run experiments, right? Imagine you have each experiment or each sample, for example, that you want to analyze and collect data on, and you want to generate this data ingestion sheet. I've just manually populated it with for demonstration purposes. So you'll get two sheets, okay? So the reason for giving you the namespace sheet is because in case the namespaces or the URIs change, for any one of these vocabs or ontologies, you can update it there. Or if you're using something that I'm not using in the default settings that I have prescribed in the FAIRLinked package, you can always append to these or change it out or delete some, and then that would get updated. So that is just one thing to mention. So what happens is it takes in the combined MDS onto. So the combined one, right, is essentially think about your low level ontology that you have made, like this one, right? This low level ontology, which is here. So I have all these green terms and all these yellow terms which extend upon PMDCO terms, and then these green terms extend upon these yellow box terms, right? So this is your low level ontology, right? And then you also have the top level ontology. Essentially, what you're doing in this combined MDS onto is you're tracing a path from these green stuff, which I'm interested in collecting data on. You're tracing a path from these all the way up till we reach one of those broad categories in the top level term, which is one of these top level categories, which is tool, recipe, result, and so on. Again, these are like non-exhaustive, so feel free to append and like improve on this. This is just to show you guys what is the algorithm behind it. So what happens is this combined MDS onto, it traces a path from those leaf nodes that I talked about in my previous video. So those leaf nodes that you want to collect data on, it traverses those leaf nodes all the way up till it hits a top level hits the top level category terms, and then it figures out which category does your particular term belong to. So for example, instrument ID was defined in my lowest level MDS ontology. Instrument ID extended upon MDS ID, for example, and then MDS ID was connected to PMDCO ID. MDS ID was also SKOS broader related to a tool, for example. So what happens is you're essentially saying that MDS instrument ID broadly belongs to tool. So I figured that out because I was able to traverse that path from MDS instrument ID, subclass of MDS ID, all the way up to SQS broader to MDS2. So the reason for doing all this categorization is so that once you're done with converting your experiments and you want to do lots of analysis on that, right? You want to figure if experiment one or experiment two, or if you want to look at it from a sample perspective, if my sample one and sample two happen to share the same tool, which means that they share the same values for instrument ID, instrument name, and instrument make. So if these two rows of values were equivalent for terms that were categorized under tool, that means your sample or your experiment used the same tool. So that is the idea behind this categorization. And just so that I reiterate or give you guys like a TLDR, you need to put in your lowest level MDS ontology, which means this XRD proof of concept. You can refer to it. I want to collect data on facility. I want to collect data on station, and all of these green terms right here. I will make sure that they are mapped all the way up to a top level MDS term, and also make sure that the broader category stuff is also mapped. So let's say I go back to my example here. Instrument ID was a subclass of MDS ID. So I would have made sure to put in instrument ID instead of this green term. And then I would make sure the subclass that instrument ID was a subclass of MDS ID. I would put it here. And then in my top level term, because of the fact that top level ontology, because of the fact that MDS ID is already related to MDS2 via the SKOS broader relationship, eventually I'll end up with a sheet which says that MDS instrument ID is related to MDS2. Okay, so the eventual purpose of this is so that you could compare different samples or different experiments and to figure out if they share the same tool, same recipe, result, sample, and so on and so forth. This is non-exhaustive. This is under development. So I hope you guys continue to build upon this, and this is exactly what the domain analyzer kind of takes in. It takes in your lowest level ontology, it takes in the path. The combined is basically the path from your leaf node all the way up, and then it outputs this to sheets for you to just look at and append data to if required. Thank you.